Hi guys, so in this video we're going to be looking at the per unit system. The per unit system is basically a method of um, transforming all your measurements into one common unit, and then it just saves. It's quite good in complicated networks, and it saves you having to worry about running through too many different sort of transformers and all that kind of thing. It just keeps everything the same. You don't have to worry about voltage drops and all that kind of thing. It keeps everything the same sort of unit, and it makes the system a lot easier to work with. So um, the per unit value of any quantity really is defined by, so you'd have per unit value equals the actual value divided by the base value. So that's value, and it'll become more clear as we go on. But so if you imagine for actually we'll run through some formulas and then we'll do an example to make things easier. So for your base voltage, you would have V base equals VL, which equals root 3 to your phase voltage. That's your line voltage, which equals root 3 to your phase voltage, and that's V base. So your base, just do them side by side, base power. So the base power is usually given in MVA ratings, say like the transformer, and you tend to try and pick the most common one, because everything, it's all based on your base power. That'll become more clear uh, in a minute when we do an example. But then you've got your base current, so your base current, which is I base, which equals your base VA, which would be your base power. So whatever you pick as your base VA, you have to keep that throughout the whole conversion. So if you pick, say you have like a system with 5 10 MVA transformers rated at 10 MVA, and then you have like 120 MVA, you would convert the 20 MVA into a 10 MVA base to just keep it common. You will go run through it in a sec. So that would be root 3 times the base voltage. So it's basically that would be V base there. This one is V base, which is this one here. Then we have your base impedance. So your base impedance is your Z base, and that can be your phase voltage over your phase current, or your line voltage, so VL over root 3 over your line current. Just make this easier, and we'll put line current. Or you could have your base voltage, so your V base over root 3, divide that by your I base. Or you could have your V base again over root 3 over your base VA divided by root 3 times V base. Or simply, which is probably most commonly used, you could use V base, which equals V base, Z base, sorry, equals V base squared over your base VA. So let's just do a little example. So say we have a system here. Right, so let's say we have a system where we have so substation A as 33 kV fault level, 2500 MVA. Then we have another substation here, so substation B, 33 kV fault level, 2200 MVA. Then you have two transformers on this one. Each transformer is 20 MVA. XT, so the transformer's reactance is 0.05 pu, so pu values might be already given. Sometimes they do this for transformers. It could be expressed as a percentage or a pu value, so yeah. And then let's say we have, if it's expressed as a percentage, so basically 100% equals 1 pu, or 50% equals 0.5 pu, which means 5% equals 0.05 pu. So that would be that would have a reactance of 5%. Three transformers down here. It's quite rough, but all on here. So three transformers at 10 MVA. XT equals 0.06 pu. And then we have what you'd have seen here. So you've got a normally open point. So that's open. And then you have your first line, which is XL 0.24 ohms per kilometer, and say 6.25 kilometers long. And then this line, XL, which is also 0.24 ohms per kilometer, but this one is 8.35 kilometers. And this is the 11 kV bus. So 33 11 kV transformers, 3 here, 3 on this one, 2 on this one. So how do we convert all units into per unit values? Okay, so it makes sense to use either, like I said before, so for your V base, which is your base power, which is your VA base, or your base VA, sorry. it makes sense to use either 20 MVA because of this one, or 10 MVA because of this. So if you've got a huge, big network, and you've got 10 MVA transformers and 5 20 MVA transformers, you go for the 10 MVA because it's the most common one, just to make things easier. It means you don't have to do too many conversions. So first, what we'll do is we'll calculate the Z base, which is the V base squared, like before, over your base, VE. So your V base is whatever your voltage is on that particular line. So up here it's 33 kV, so anything sort of north of this point will be 33 kV. But because we're looking at this line reactance here, we're working with 11 kV, but it's on the 11 kV bus. So this is going to be 11,000 squared over your base VA. So you can either pick 10 MVA, 20 MVA here, or 10 MVA, whichever one. It's up to you, it doesn't matter. But we'll pick 10 MVA because we've got 3 10 MVA transformers here, we've only got 2 here. So let's say 10, so that's times 10 to the 6 because it's MVA, which is 12.1 ohms. So next we'll calculate the value of the total value of XL. So, oh no, I don't know why it's done that. Show that out quickly. Okay, so I'll do right. So that was equals 12.1 ohms. Just turn it down a little bit. Okay. So what we'll do next is we'll calculate the total reactance of both the lines. So basically you've got you'll have the total length of the line, so L, which equals 8.35 plus 6.25. So L equals 8.25 plus 6.25, which is 14.6 kilometers, which means, let's move this further down. So total value of XL is 0.24 times 14.6, so 0.24. So that means XL equals 3.504 ohms. So that's the total length of this line all the way down. Do it in different color pens so you can see a little bit better. So it's all the way down this line, all the way down there, and up here, and that's these values here, these ones. So then to calculate the per unit value, so the cable and the cable impedance between the two substations, so substation A and substation B, will be 3.504 divided by your Z base value, which is 12.1. So then your total value will be 0.286, 96 pu. So that's how you get your per unit value for your cable. So if we start drawing this out down here, so basically if we draw a little resistor representing the cable, it's 0.2896 pu. So if you imagine that's the cable, then you have your 3 transformers there, all connected on your bus. Two transformers on this side, again connected onto this bus here. So what do we have next? So we have so let's go with this the fault level of the 33 kV system at substation A. So that's it's 2500 MVA, and that basically means that the fault level at that substation is 2000. It's 1 pu at 2500 MVA. So on our 10 MVA system, it's basically 1 times 10 over 2500, and that'll give us 0.0004 pu. So if it's 1 pu on a 2500 MVA system, that means it's 0.004 pu on a 10 MVA system. And the same goes for the fault level of 2200, so that's basically 1 pu at 2200, which means it's 2200 here, which will equal 0.045, so 0.0045 pu. And so that's the substation per unit values. So now all we have left is the 3 transformers at substation B and the 2 transformers at substation A. So what do we know about them? Well, because we use the 10 MVA from, just get rid of that. Because we use this 10 MVA figure here, the bases stayed the same for these 3 transformers. So basically the reactance in per unit values shown here is the same as the one down here, because it's the same base, so that's 0.06 pu all the way through for all these, and 0.06 pu there. And this one was a 20 MVA at 0.05. So what we have to do there is we go for the 20 MVA base, we'll have, put it down here, 10 over 20, and then multiply that by the, is it 0.05? 0.05 pu, 0.05. So then that'll give us 10 over 20, which is a half, times by 0.05, which is 0.025 pu. So these ones 0.025 pu, 0.025 pu there as well. So that's how you convert your system into per unit values, and then from there what you can do is you can work out the parallel values of these circuits here, this one and these one here, and then you can add them all together to create one simple value. So we'll have a look at that now actually. So if we imagine that a fault turns up at this point in the network, so it's a fault to earth, what we have to do is display all these values. So that's your substation A, maybe 2 transformers just here. This one's also 0.025 pu as calculated before. Now because it's on this side of the line, our line reactance goes here, 0.2896 pu, and then all of this is in parallel with our three transformers at this side, which were 0.06 pu each. So that's all three of them. And then this was 0.005 pu just here. So then what we can do is we can calculate the parallel impedances per unit values of these just by using simple parallel and series techniques. So what you end up with, so basically if we reduce this down, so say for instance this one here, you would have 1 over 1 over 1 over 0.025 plus 1 over 0.025. It's kind of similar to what we do in Ohm's law. And that would equal 0.0125 pu. So then you'd end up with a system, just put it over here, so you would have 0.004 pu there. Then you can reduce this down to 0.0125 pu, and again you've got your line here, 0.2896 pu, and don't forget this is your faulty network here, so this is where your fault is. Oh, quite a thin one. So then you would have your three transformer values using this same method here in parallel, but with the 0.06 figures, and that would come to 0.02 pu. And also from before you'd have a substation 0.0045 pu. And then using series technique, so it's basically this value plus this value here plus this value, and then this value here plus this value here, you'll end up with two simple resistors, 0.0361, and then one here, 0.0227. These are PUs. Oops. Fault here. And then finally, using your parallel technique like this one again, you just do for this resistor and this resistor, this per unit, these two per unit values there, sorry, and you would finally end up with one by itself, which would be 0.0227 pu. And then from there you can calculate things like your fault level and your fault currents through your network to try and give you a better understanding what's going on. So yeah, that's basically how you convert into per unit values. For more information, check us out at worldofetc.com and also click and subscribe below.